Mastering gravitational acceleration and freefall. Physics made simple. Ever wondered why everything falls at the same speed? Let's uncover the secret behind gravitational acceleration. Gravity pulls everything down at a steady rate of 9.8 meters per second squared. That's what we call acceleration due to gravity, or just g. Whether you measure it in centimeters per second squared or feet per second squared, it's always the same force tugging us down. And here's something cool, because gravity pulls downward, we give it a negative sign in physics equations. It's like a downward arrow in math. Now, imagine dropping something. If it's accelerating only because of gravity, boom, it's in free fall. Free fall means the object's motion is driven by gravity alone. No other forces like air resistance, just pure gravitational acceleration. If you throw a ball up, guess what happens? It slows down by 9.8 meters per second every second until it stops at the top. That means it's accelerating downward at minus 9.8 meters/s squared. Then, the ball comes back down, speeding up by 9.8 meters per second each second, still falling freely and accelerating downward. Both going up and coming down? Yep, both are free fall. Just gravity doing its thing, pushing and pulling the object vertically. When dealing with free fall, you use the same equations as uniform acceleration, but tweak them with a negative sign to reflect gravity's downward pull. Throw something up, and its velocity drops by 9.8 meters per second every second until it stops. Then it drops, gaining velocity by 9.8 meters per second every second. Simple physics magic. Here are some key free fall formulas you gotta know. Final velocity equals initial velocity plus gravity times time, Vf equals Vo plus gt. Displacement? It's initial velocity times time plus half the acceleration times time squared, d equals Vot plus half gt squared. And don't forget, the velocity squared formula. Vf squared equals Vo squared plus 2gd. It's a handy one for all your free fall calculations. Average velocity? Just the mean of initial and final velocities. Vave equals Vo plus Vf/2. Easy, right? Let's see this in action. Imagine you throw a ball upwards at 20 meters per second. How long before it stops rising? Using Vf equals Vo plus gt, and knowing the velocity at max height is 0, we get 0 equals 20 plus, minus 9.8 t. Solve for t and you get about 2.04 seconds. Next, how high does the ball go? Using Vf squared equals Vo squared plus 2gd and plugging in 0 for Vf, we find the max height to be around 20.41 meters. Finally, total time in the air is just twice the time going up. 2 by 2.04 equals about 4.1 seconds. That's the full flight. Ready for another? A boy tosses a coin up at 14.7 meters per second. Let's find the max height the coin reaches. Using the same velocity squared formula, we calculate the coin's max height at around 11 meters. How long does the coin spend in the air? Upwards trip takes about 1.5 seconds, so total flight is roughly 3 seconds. What about when the coin returns to the boy's hand? Its velocity is minus 14.7 meters per second, same speed, but now heading downward. If the coin slips past the hand and drops the last 0.49 meters, it'll hit the ground at about 15 meters per second. That's one speedy coin. So there you have it. Gravity is constant, powerful, and shapes all falling motion, whether a ball or a coin. Next time you toss something up, you'll know exactly what's happening behind the scenes. Science at work. If this got you curious, like and share to spread the free fall fun. And drop a comment with your favorite throw or fall story.